Welcome back to Mr. DuPage's classroom. This is a lesson for my CP Algebra 1 class. This is the lesson for Monday, August 8th. This is a lesson over variables and combining like terms. Let's get right into the lesson. As I said before, this lesson is for August 8th. So make sure we have 8/8 on the date line. First thing is we have a warm-up. Please take 2 minutes to try the warm-up. Let's see how you did on the warm-up. Number one, first thing we need to do is everything that is inside of the parentheses. Well, inside the parentheses, I have an exponent. So I need to work with the exponent first. I'm just going to bring down my -2 and my parentheses. 5 squared is 25. So 25 minus 15. Inside the parentheses, I will divide by 4. So just bring that down as well. Still, we need to work inside the parentheses. So I have 25 minus 15. Bring down my -2. Parentheses, that is 10. Make sure we bring down our divided by 4. The next thing I'll look at, do I have any more parentheses or any more I have to do inside that parentheses? I do not. So it's just a multiplication problem here and a division problem here. According to PEMDAS, or order of operations, I can just do those left to right. So -2 times 10 would get me -20, and that would be divided by 4. -20 divided by 4 then is -5. Looking at problem number 2, I want to work inside of any grouping symbols. Absolute value, as you see here, there's one absolute value there and one absolute value there. They are grouping symbols, so I want to work with inside the grouping symbols first. So looking at the first grouping symbol, I have -3 minus 7. That is going to get me -10 plus grouping symbol. I have 4 plus 2 to the 3rd power. According to order of operations, I need to work with the 2 to the 3rd power first. So it'll be 4 plus 2 to the 3rd power is 8. It's 2 times 2 times 2. Next thing, look at your first set of order of operations. There's nothing more I can do with that right now. I could take the absolute value if I want, but because there is something I can do with the second absolute value, I will not do that yet. I'm just going to bring that down. In the second absolute value, I have 4 plus 8, and that's going to equal 12 inside the absolute value symbol. What is the absolute value of -10? Well, it is just going to be 10. Absolute value of 12 is just 12. So I have 10 plus 12. My final answer will be 22. Last problem. I have an exponent that is working outside of my grouping symbol, which is a parenthesis. If that were to happen, I'm going to take the exponent to the 1 and to the 2. So it's really going to be 1 squared over 2 squared plus the 7 over 8. Well, 1 squared is 1, 2 squared is 4, plus 7 over 8. And just like we talked about the other day, if I have two fractions and I want to add up, I need to make their denominators the same. In order to do that, I need to multiply that fraction by 2, 2 over 2. When I multiply 1 by 2, I end up with 2. 2 times 4 is 8, plus the 7 over 8. Now I can just add my numerator and my numerator together. I'll end up with 9 over 8. And that is in simplest form. Hopefully you did pretty well in the warm-up. If you did not and you have a question about it, please feel free to ask. But let's continue. Variable. It is a symbol using a letter that represents one or more values or numbers. Values, also known as numbers. The notes about a variable. A variable can represent an infinite amount of of values, or possibilities of values. At the exact same time. Now, that might be a little confusing, but hopefully after this example, you'll get what it means. The example would be if I have a expression that says x plus 1. The x can represent a infinite number of, or I can put any number I want in for x, as long as it makes the expression true. So it could be 0 in for x, so that'd be 0 plus 1, or it could be 2 plus 1, or we could have 3 plus 1, or it could even go up to something like 100,000 plus 1. So in those examples, 0 went in for x, 2 went in for x, 3 went in for x, and 100,000 went in for x. All x is really saying is that there is some number there that I don't know what it is right now. So basically what it turns into is just a big puzzle that we have to solve what will go in that piece for x in order to make the puzzle true. Now, an algebraic expression is a mathematical phrase that can include numbers, variables, and operation symbols. The example I just used, the x plus 1, is an algebraic expression. Note, there is no equal sign in an expression. If there's an equal sign, that's actually called an equation. Right now, we're just going to be working with algebraic expressions. The number in front of the variable is going to be a coefficient. The word coefficient, you want to remember that. So, for example, 12x. 12 is your coefficient, just that little part. That is your coefficient. In the second example, I have negative 5, x to the fourth. Well, the coefficient there would just be the negative 5. That is your coefficient. And really, in those situations, what that is saying is I'm going to take the number 12 and multiply it by x. Or I'm going to take the negative 5 and multiply it by x to the fourth. So we're going to go ahead and try some of these. What we're going to have is words. They're going to tell us what we're trying to do, and we have to write the algebraic expression. So if I have 12 more than x, if I'm saying I have something is more than what I started with the second part, right? So I'm going to start with x. If I say I have more than, that means I'm going to add the number 12. So it'll be x plus 12. Anytime you have a than, a more than, less than, anything along those lines, we're going to switch the order of how it's read. Okay? Number 2, the difference of y and 6. In this one, I do not have than in the problem, so we're just looking at the word difference. If I have the word difference, I'm just going to subtract from left to right. So in this problem, my y comes first, so it'll be y, and my 6 comes second, so it'll be y minus 6. In number 3, I have less, but it's not less than. So again, it did not tell us to switch the order, so I do not have a than in there. So in this problem, it would really just be 7 minus P. Less is the key word there that tells us it is subtraction. What about if I had 7 less than P though? If I had 7 less than P, again, less tells us we have subtraction. Than tells us we need to switch the order. We need to switch our order. So in this problem, it would be P minus 7, because it's 7 less than the thing I had originally, which was P in that problem. Let's look at number 4. We have the product of R and 9. The key word here is product. Hopefully you remember, or you have been taught before, that product means multiplication. So I can write this a couple of different ways. I could write this as R times 9, or, and how you're going to see it more often, is 9 times R. There's also another way we could write this, and it would be R times 9. If there's something just outside of the parentheses with no addition or subtraction in between, it just means multiplication. Number 5 gets a little tricky. I have 10 less than 3 times a number. And a number is a little tricky as well. Well, less than tells us it's going to be subtraction, and we're going to switch the order. Times means multiplication, and there is no than, so we're not going to switch our order. If it says a number, it does not say, so it doesn't say what the number is. So we're just going to use a variable. We will use a variable to hold that place. So since it says less than, I'm going to start with the multiplication problem. It's 3 times a number, so we start with that. It would be 3x. Less than means subtract, so it would be 3x minus 10, because it's 10 less than 3 times a number. So this 3x is our 3 times a number. Here's our 10. The subtraction in between it came from the less than. Number 6, I have the quotient of 4 and a number. I have the quotient of 4 and a number. Quotient means divide, and it will just be from left to right. So 4 is the first, a number is second, just like we talked about in number 5. If it does not specify what the number is, if it doesn't tell us exactly what the number is, we'll just use a variable. There's a couple different ways you can write this as well. I could write it as 4 divided by x, or I could write this as 4 divided by x. This is the way you're going to see it most often. So in summary, we have a bunch of different words that mean a bunch of different things. Let's go ahead and write those down so that you have a list of what all the words would mean. So more would mean add. I'm making more of something. I'm getting more of something. I'm going to add to it. The next one would be sum. That would also mean add. The sum of 2 numbers. That's an addition problem. The next one we'll work with is less. Less would mean subtract. I'm taking something away from it. Also, the difference would be a subtraction problem. So we're going to subtract when we see difference. Okay. The next word is product. As we talked about up top, if we have the word product, it means to multiply. We have times would be another multiplication problem. If it says times, we want to multiply. And quotient is our last word, which we just saw a second ago, means we're going to divide. Actually, I want to put one more word in here. What does it mean if it says more than or less than? Well, than is usually a good indication that we need to switch the order. We want to switch our order. Oh, can't spell order right now apparently. Switch the order. Okay, let's move on to the back. Adding and subtracting variable expressions. When adding and subtracting variables, do not change the exponent. Just add or subtract the coefficients. You can think about it like combining xylophones or zebras. Xylophone starts with the letter X. That's why we have X's in this problem here. So if I have 5 xylophones and I add 19 xylophones to it, I'll end up with 24 xylophones. Same thing goes for our zebras here. If I have 16 zebras and I take 10 of them to another zoo, then I will only have 6 zebras left. Okay? Part 2, we're going to talk about the difference of our exponents. X squared, and x to the third. So x squared, and x to the third, they do not mean the same thing. You cannot combine those variables with different exponents. So if we have a problem, something like x plus 2x squared, that does not equal 3x squared. Okay? Always remember that a variable is just another name for a number. So we're going to let x equal 5. Is 5 the same thing as 5 squared? Well, 5 is equal to just 5, right? 5 squared is equal to 25. So those are not the same thing. That would be the same thing. Let's use a variable in its place. X and x squared do not mean the same thing. So is 5 squared the same as 5 to the third? Well, 5 squared is 25. 5 to the third is 125. Those are not the same thing. That would be like saying x squared and x to the third are the same thing, and they are not. So the last part here, we're going to talk about combining like terms. I will go through 2 problems with you right now, then I'll give you a couple minutes to work through it, and let's see how you do. So in problem number 1, I have 3x plus 9x plus 5x. All I'm going to do to start with is I'm going to add the 3x and the 9x. Just bring down my 5x. Well, 3x plus 9x is 12x plus 5x. 12x plus 5x is 17x. I'm going to now jump down to 4. Actually, let's go to 3 first. Just like we talked about with the different exponents, I cannot combine this 4x squared and that 8x. The 8x is something different than the 4x squared. But I can combine the 4x squared and the 5x squared. Well, 4x squared plus 5x squared will get me 9x squared. The 8x squared, or the 8x is just by itself, so I'm going to keep the sign plus 8x. That would be our final answer. Now we'll jump down to number 4. Again, I can only combine them if the variable is exactly the same. So just like with the different exponents in problem number 3, if the variable is not exactly the same, I cannot combine the exponents. So the first thing I'm going to look at, this 20y, what can it be combined with? Well, the negative y here. So 20y minus y would get me 19y. The next thing I can combine, the negative 7x and the positive 10x. Well, negative 7x plus 10x would actually be positive 3x. You can also think of that as 10x minus 7x in that situation. The one last thing I want to talk about, whenever we rewrite algebraic expressions, we want to write them in alphabetic order. We'll write them in alphabetic order. Right now, this is not in alphabetical order. That is not in alphabetical order. So in order to write it correctly, we would need to write it 3x plus 19y. Okay? Now, what I'm going to do is give you 2 minutes to try 2 and 5 through 8. All right, looking at number 2, I can combine these all together because they're just the same variable. So I have 10y minus 13y. That would get me negative 3y plus 2y. Well, negative 3 plus 2 would get me negative 1y. When I have a variable and a number out front, if there's ever a 1 out front, I do not need to write the 1, but I would need to keep the negative. So you could write it just as negative y. I would accept negative 1y though. I would take that. That is fine. Let's move on to number 5. I have 4x squared as my first number in the line. What can I combine that with? Well, I can combine 4x squared with 2x squared. The sign in front of the 2x squared is positive, so it would be 4x squared plus 2x squared, which would get me 6x squared. The next thing I need to look at, I can go ahead and I cross those out after I take care of them. Once I know that they're done, I get them out of there so I don't have to look at them anymore. Next number I have is positive 6x. Well, I can combine positive 6x with negative 9x. So this would be like 6x minus 9x. That would get me negative 3x. So those are now done. The last two numbers I have, positive 7 and positive 1. So this would be 7 plus 1, which is now positive 8. And now those are done. Looking at the answer that I have on the board, can I combine any of those together? Do I have another x squared up there? No, I don't. Do I have another just x up there? No, I don't. Do I have any other numbers that do not have a variable? No. So this is actually my final answer. Every time you come to a point where you have a final answer, please box it. I know I forgot to do that over here. I'll do it now. But please make sure you're boxing your answers. That will just help me find them later. Look at number 6. I have a 6x to the third. Are there any other x to the thirds in that problem? There's not. So I'm just going to go ahead and write that down. 6x to the third. And we know that is now done. The next thing I have is a positive 5x squared. What can I combine the positive 5x squared with? Well, I can combine it with the positive 3x squared. So that is 5x squared plus 3x squared. That will give me positive 8x squared. The last thing I have up there is the negative x. Go ahead and keep the sign with it. Can I combine anything else? No, I can't. So I'm going to go ahead and box my answer. You do not have to make the boxes in the problem if you don't want to, or circle anything. That's just how I tend to help myself stay organized. Problem number 7, I have 3x to the 5th. Is there another x to the 5th? Yes, there is. It is a negative x to the 5th. Remember, just like we talked about in problem number 2, if there is not a number in front of a variable, it really is just a 1. If you want to write that in for yourself, just for a helpful reminder, go ahead and do so. So I have 3x to the 5th minus 1x to the 5th. That will give me 2x to the 5th. My x to the 5ths are done now. Then I have a positive 4x. Is there another just x in this problem? There's not, so I can go ahead and write that down. The last piece is the positive 9x. Make sure you're keeping the sign with it. There's not another x squared, so it'll be plus 9x squared. Now, just like we talked about in problem number 4, when we want to write those in alphabetical order, when I do not have different variable letters, so they're all x's, but my exponents are different, I want to write this in descending exponent order. So I really want to write this as 2x to the 5th plus 9x squared plus 4x. This will come in handy later when we're looking at some graphing things, but it's just called standard form. You write it in descending order. That is known as standard form. Okay. The last problem, number 8. I have a couple different variables here, so we got to make sure we're being careful. First number I run into, negative 15x and a positive 5x. What is negative 15x plus 5x? That would get me negative 10x. Okay. We know those are gone now. I don't have to worry about them anymore. Next thing I come to is a positive 10y. A positive 10y. That can be combined with this negative 7y. Well, 10y minus 7y would be positive 3y. Finally, I just have the plus 3. I'm going to go ahead and just write plus 3. That is correct. All right.
And that will conclude our lesson. Your assignment is the worksheet titled 1.1 Variables and 9.1 Combining Like Terms. You should have picked that up on the way in the door. The most important things from this lesson you need to remember: what a variable is. That it's just a letter that represents some number we're trying to find. That's the most important thing about a variable. The next thing is algebraic expressions. They're just letters, they're just variables and numbers and possibly operations, but there's no equal sign. That is the difference between an expression and an equation. Another thing is the coefficient. It's just the number that comes before a variable. There will not be a plus or minus in between. It will be attached to the variable. That's what a coefficient is. Also, make sure you study that summary box down at the bottom that we went through. It has all the more, less, difference, sum, product, all those good words. That way you know if you ever see a situation where it's telling you that I need the product of two things, you know exactly what to do, okay? And finally, when we're adding or subtracting variables, that we know we can only combine like terms. Remember that like terms are the same letter, but also the same exponent. So if I have an x and an x squared, those are not the same thing. All right? Those are the most important things from this lesson, and have a great day.